All right, so now let's talk about heating curves. So we mentioned we were going to talk about the heating curve as it relates to a graph, right? And seeing at what temperature and time it turns into a solid, which time and temperature it turns into a liquid, and then a gas. And so remember again, the kinetic energy is just about motion, right? So whenever you hear the word kinetic, think of just motion. So kinetic energy is the motion of particles, and it's related to temperature. Remember that, y'all. Everyone always forgets this on the midterms and the finals, is that the higher the temperature, the faster the particles move, right? And we saw that with the simulation. As we turned the temperature down, the particles stopped moving and they just got really slow. And then as we turned up the heat, the particles started moving faster and faster, and they were just kind of bouncing all over the walls, right? So remember, higher temperatures, higher kinetic energy, more movement. Potential energy is just the space between particles, and it's related to phase changes. And we're going to see that in a little bit at why at like 0 degrees, this happens. And then again, at 100 degrees, this happens. And we'll see that on the graph in a little bit. And so here again with these heating curves, remember these terms, right? There's going to be two terms, heat of fusion and heat of vaporization. So remember what they mean. Because here at 0 degrees, so you see right here the definition, heat of fusion is the energy required to change from a solid to a liquid, right? Some attractive forces are broken. So this is why it's no longer going to be in that solid cube shape. Now it's turning into like a puddle, right? So this is why it's doing that, is because those attractive forces, kind of like pieces of tape holding it together, as soon as the heat starts coming on, those pieces of tape start melting and start being broken. And now it's no longer a solid cube shape, it's turning into a puddle. Because again, those things that were holding it together are starting to break apart with the heat. So the heat's going in there and breaking up all those things, keeping it together as a cube, and that's why it melts into a puddle. All right, so that's again going from a solid like ice to a liquid like water. Right, but then you have, and we're still talking about the heating curves. Now you have what we were talking about earlier, heat of vaporization. So remember, the one before this right here was just called heat of fusion, and that's going from solid to liquid. But now we're talking about heat of vaporization, and this is going from a liquid to a gas. So when it starts to boil, and this is just saying that all of the forces that were holding it together, so all of those pieces of tape that were holding it together, they are completely gone now, right? So now instead of it being a puddle of water, now that those forces are broken that were holding it together, now these little water particles are like, oh, I'm free, and they're just like busting off into steam, right? They're just breaking out of the water and going up in the air as steam. And they have a lot of energy coming with them. And that's why, again, if you ever have like boiling water and you put your arm over it, that steam is going to burn you. That steam actually has more energy than the boiling water does. And that's why it hurts so much. And it'll leave like a really red mark on your arm because of all the energy that this steam has. Right. So here you see this. This is what I was talking about. At 0 degrees right here, you see that it is flat, right? It's rising here below zero, which means that the temperature is going up, right? But it's a solid. But when you hit 0 degrees, and this is where I was saying that the melting point and the freezing point are the same thing, it's happening right here at zero, right? So anything below it turns into a solid, anything above it turns into a liquid. And you can see it right here, liquid, and KE is just for kinetic energy. That again means that they're just starting to move more. And so it's flat right here at zero because this is where the heat of fusion is happening, and it's breaking some of those things that are holding it together, right? Some of those bonds that are holding it together. I keep calling it tape, but they're called bonds, right? But they're kind of breaking here, and that's why it's flat. That's why it doesn't just go continuously like straight up. It's got to be flat here because some of those bonds are being broken. And then it rises and rises and rises. This it's liquid right here, but then at 100 degrees it gets flat again. And this is because the rest of the bonds, again, those pieces of tape that were holding all the water together in a puddle, now those are broken. And it takes this time right here for it to break all of those completely. And then once it breaks those completely, then the water particles turn into a gas, right? It starts boiling and then it just steam starts coming out of the water. And so right here, that gas is happening and it's at this point right here. So again, it flatlines right here at zero, and then it flatlines right here again at 100 because the bonds that are holding these things together are being broken. Here they break and it goes from a solid to a liquid. Here the bonds break and it goes from a liquid to a gas.